What we're going to do is we're going to look at arithmetic sums. There's two different arithmetic sums. One finds the sum if you're given a first term and a last term. The second one, you find the sum if you're given a first term and a common difference. So if we look at our first example, what we see is that they give us a first term and a last term. So we're going to use our first formula. We're going to find the sum of 16 terms because our last term is the 16th term. And we're going to put 16 times, and then in parentheses, 2 plus 77. And then what we're going to do is we're going to divide it by 2. And that right there gives us an answer of 632. For the next one, we're going to do the same thing. What we're going to do is we're going to find the sum of 15 terms in this case, because our last term is 15. So we have 15, and then we have -9 plus 47, and then we're going to divide it by 2. And that right there gives us a sum of 285. For letter C, we're going to do the same thing. We're finding the sum of 14 terms because our last term is 14. And that would be 14, and then in parentheses, -20 plus 19. And then what we're going to do is we're going to divide it by 2. And that right there gives us a sum of -7. Now for our next ones, what we're going to do is we're going to find the first 12 terms. And notice that they're not giving us a last term because it has a dot, dot, dot. We know our first term is -2, and we see that it's going up by 6. So we're going to find the sum of the first 12 terms. We're going to go 12 over 2. We have 2 times -2 plus we have 12 minus 1. And our common difference is 6. And that right there gives us a sum of 372. For the next one, we're going to do the same thing. We're finding the sum of 12 terms. It would be 12 over 2. We have 2 times -8 plus we have 12 minus 1, and then it's going down by 2. So we put -2. And that right there gives us a sum of -228. For letter C, we're going to do the same thing, the sum of 12 terms. We have 12 over 2. We have 2 times 3 plus, and then what we have is 12 minus 1. And we see that our common difference, it's going up by 5. And so that right there gives us 366. Now, in the history of math, there's a famous mathematician named Gauss. And when he was, the story goes, about 7 years old, his teacher had him add up the numbers 1 to 100 because he finished all of his work and she just wanted to keep him busy. So he came back in a minute with the answer and he told the teacher his answer. Now, what he did is he figured out the pattern of the numbers. He didn't just go 1 plus 2 plus 3 and then keep on going. What he noticed is that when you add the first and the last numbers, what you get is 101. And when you add the second and the second to the last, you also get 101. And the third to the third to the last, you also get 101. And he realized that all of them add up to 101 and that there was 50 pairs. So he just went 50 times 101, and that gave the answer 50/50. Now, why we go over that story is because that's basically the sum formula. The sum formula, the first one, is n over 2. And then what we're doing is we're adding our first term with our last term. And that's exactly what Gauss did. He took the first one and the last one, and that's how he got the 101. And then what he did was he counted how many numbers there are. That's 100. And if you divide it by 2, that tells you how many pairs there are. And that right there is where the 50 came from. And so that's how he came up with the answer so quickly.